Since 2023, executives predicted AI will soon replace most software engineers. Given the raw capability of modern coding agents, that anxiety is understandable. These systems consistently demolish industry benchmarks and win technical competitions. They generate functional code 10 or even 100 times faster than a human programmer. But this massive speed increase has produced a strange result. The number of job openings for coders has actually continued to rise. This paradox is explained by the theory of constraints. Jobs function as interconnected tasks, much like water moving through a pipe. AI widens the coding section, but it still hallucinates. Humans spend their saved time debugging, so the bottleneck just moved downstream. AI hasn't failed to take over the workforce because it lacks intelligence. It is currently trapped by a series of invisible, escalating real-world barriers. In 1976, Stanford researchers built an AI system called Mycin to diagnose severe bacterial infections like meningitis. In testing, its acceptability rating outscored most human infectious disease specialists. Despite its accuracy, Mycin was never used on a single patient. The system required nearly an hour of manual data entry for every diagnosis. Instead of saving time, the AI created a massive clerical bottleneck for doctors. By 2011, IBM's Watson attempted to bypass this by using digital medical records. Yet within a few years, its cancer treatment project was shut down. Watson was trained on clean, standardized data, but real hospital records are chaotic, filled with jargon, abbreviations, and rare medical exceptions that the AI couldn't interpret. This is the last-mile problem. Laying a main data cable across a country is straightforward engineering. Connecting that cable to thousands of unique, unpredictable individual endpoints is exponentially more complex. We see this today with self-driving cars. They perform beautifully in controlled settings, but struggle with unusual weather, construction zones, and unpredictable humans. The chaotic last-mile variables that people handle intuitively. Every company and environment adds its own unique exceptions. Raw AI capability remains secondary to whether or not the system can actually navigate the messy reality of a physical workplace. Even if the technology works perfectly, it still has to solve a human problem. One appliance manufacturer recently automated their customer support intake with an AI that processed and assigned tickets instantly. On paper, the system was a success. Tickets moved faster than ever. However, customer frustration peaked and negative reviews increased. The company discovered that the automation was merely masking the root problem, confusing instruction manuals. They eventually reverted to human phone support, realizing that talking to customers provided the product insights needed to fix the manuals in the first place. This dynamic also played out during the ATM rollout in the 1990s. The common assumption at the time was that automated machines would eliminate the need for human bank tellers. Instead, ATMs made banking cheaper and more convenient. This attracted so many new customers that banks opened more branches, leading to a net increase in teller hiring. This is demand expansion. If AI drives down the cost of specialized services like healthcare or software development, millions of new customers will enter the market, potentially creating more jobs than the technology replaces. Even with a ready market, technology is gated by infrastructure. In 1882, Thomas Edison built the first commercial power plant. It took 50 years for electricity to change how people worked. Early factories simply swapped their steam engines for electric motors without changing their layouts. They were trying to use new power in an old system. The real transformation required rebuilding entire cities, establishing new safety codes, and training a generation of specialized engineers from the ground up. Modern AI is hitting these same physical limits. Data center projects are currently being paused due to severe power grid shortages and a lack of specialized electrical equipment to handle the load. We are also missing the social infrastructure. Laws regarding AI ownership are unresolved, workforce training is lagging, and the long-term commercial viability of these massive energy costs remains unproven. Even a super-intelligent system remains limited by the physical and social grid of the planet. Until that infrastructure is rebuilt, the technology cannot be fully adopted. These bottlenecks don't prevent short-term disruption. Technological adoption is ultimately bound by the social and legal frameworks we choose to support. Because these systems rely on the infrastructure we build and the laws we pass, the future of this transition depends on our collective decisions.